Welcome friends to the course of marketing research and analysis. So, in the last lecture we had started discussing about the kinds of experimental designs basically, right. So, we started with the pre-experimental. There are four categories. The first category we said is the pre-experimental design, and here there were three kind of studies: the one shot case study, right, the one group pre-test post-test study, and the static group study. Second, we did with the truly experimental. So, why it is called truly experimental? If you remember, I had explained a study can be termed as truly experimental when there is an element of randomization possible in it, right. So, that means if you can randomly select the the test units and place them in the treatment or the control group, then we say it is a really experiment, it is a real experiment, because that is what experiment is all about, right. So, in an experiment we do not create any bias, we leave it to we try to be as fair as possible and unbiased as possible. Okay. So, there we said there are tests like pre-test, post-test, control group. So, you have a control group and a experimental group basically. Post-test only control group, right, and the Solomon 4 group design. So, if you remember the Solomon 4 group design, we had said there are 4 conditions where we said that, for example, you have pre-test and post-test with an experiment, right. Then we have a experiment, but only a post-test. Then we said we have a we have pre-test, post-test, but no experiment, right, post-test, this is pre and post, but no experiment. So, this is a control group basically, right. And then we said only a post group, post, this is again a control group, only a post. So, these are the 4 stages we said are there. Today we will talk about another kind of experimental design, which is very vital in the sense in the real life. It so happens that you might not be able to randomly place your test units, you might not be able to do a random testing. Why? Because it is always it is not possible that you can treat human beings the way you can treat machines or materials, right. So, what you can do with materials, maybe a pre-test and a post-test, maybe you can put in some treatment, some kind of a chemical analysis or something, that may not be able to may not be possible with human beings or organisms, right. So, in such a condition we go for another kind of test, which is a quasi experimental test. What does this mean? Quasi means resemble, to resemble. So, it means that this research resembles the experimental research, but it is not exactly that. So, as I said, there are conditions when you may not get an opportunity to do an exactly a proper experimental research, but you need to do some research. So, in such a condition you do something that is very close to the experimental research. So, that is why it is called a quasi, right. Let us see. Although the dependent variable is manipulated, the independent variable is manipulated, the participants are not randomly assigned. Now, this is important, to conditions or order of conditions. That means the test units are not randomly assigned, that is the most important term when you talk about the quasi experimental design. Quasi experiments are most likely to be conducted in field settings in which random assignment is difficult or impossible. We will see an example. They are often conducted to evaluate the effectiveness of a treatment, perhaps a type of psychotherapy or an educational intervention, right. Example, let us see. Let us say if you want to study the effect of smoking on, let us say, on a variable like smoking on the health effect, right, the effect of smoking on health, you cannot randomly assign people to smoking versus non-smoking group, because that is unethical. So, you can't ask people to go for smoking, right, because that is not ethical and it is wrong, right. Similarly, there are several other things for which we need an answer, but then we cannot test it because they are harmful to the human beings, right. For example, impact of the driving in a alcoholic condition or in a intoxicated condition. So, would you ask people to get drunk and then drive? No, you cannot do it. So, then the purely the pure experiment is not possible in that condition, but then what we can do is maybe we can check in with those people who were drunk and then what happened to their driving, that we can check, right, and what happened to people who were not drunk and they were driving. So, this difference we can see, and this difference is the closest thing that you can do to an experimental research. So, that is why this kind of tests are called the quasi experimental tests, right. So, what researchers do is to ask people how much they smoke, right, and then assign them to groups. So, somebody is already smoking, then you can ask them, well, how much do you smoke? Maybe I smoke 1 packet per day or half a packet. So, we will try put them into different groups, right, and then test it, because they are already consuming, right. So, under experimental design there are two basic conditions that we will talk about. How do you deal with the experimental design, with a quasi experimental design, right. So, in a quasi experimental design, it involves the periodic measurements of the dependent variable. So, for example, when you talked about the smoker, so you take a group of smokers and non-smokers and you try to see on a periodic basis what is the effect of smoking on the health of the smokers, right. So, I will check his heart condition maybe in a week's time, then maybe after another week's time, or 1 month, 2nd month, 3rd month, 4th month, 5th month, 6th month. So, I go and I continuously do it. So, when I do this, I can see the effect of a building effect, a cascading or a cumulative effect of smoking over the smokers say. Here you remember, as a person or as a researcher, I have not advised them to smoke, right, you have not advised them to smoke, they are smokers, they are smoking. So, you have not encouraged them to do it. So, that is why there is no problem, but in a experimental condition, had it been, you might have had taken test units and put them in a condition which they are not ready to do. For example, they are not ready to smoke and you would have requested them to do that is not possible ethically. Okay. So, there is no control group. One important thing in the kind of a quasi experimental design is there is no control group, right, you only have the experimental group here. The treatment is administered by the researcher or occurs naturally. So, either the treatment is administered or it naturally occurs, right. So, if it is a possible condition that you can give a treatment, for example, I can give a treatment of asking somebody to, let us say, eat sweets and see whether sweets induce sleep, right. They say that if you take sweets you will feel sleepy. So, to test that we can ask somebody, because it is not harmful, it is not dangerous, right, but that the same test cannot be done with alcohol, right, you cannot do that. So, the treatment is administered by the researcher or it occurs naturally, like for example, somebody having some habit, right, which is natural to him or her. Now, that is a part of that test unit's condition, right. After the treatment, periodic measurements are continued to determine the treatment effect. So, regularly we will check and see the effects. Let us see this. So, this is a one group time series design. What is happening here? This is a quasi experiment in which O1, O2, O3 are 3 time periods, let us say 3 observations have been taken, and this is the treatment has been given, and again O4, O5 and O6 are the observed that means the observation values, right. So, when you do this kind of a test, it is a number of times you are repeating, you can see the experiment and then you find out some kind of a infer some kind of a solution. So, this is a quasi experiment because there is no randomization of the test units to treatments, there is no randomization, you cannot randomly put them because randomization will become wrong here, right. So, there is some this fellow, let us say, is a smoker or a non-smoker from the very beginning, you know it, right, and the timing of the treatment presentation as well as which test units are exposed to the treatment may not be within the researcher's control. So, the researcher cannot control few things, like for example, let us say I am asking you to conduct be a part of an experiment and you are in a far off place. So, I am thinking I am trying to I am running the experiment, but then are you really participating honestly, or are you that time you are taking some rest, or you are doing something in your home? I do not know. So, there I do not have a control. So, these are the problems you have in a time series or a quasi experimental design, right. Now, look at this condition, the effectiveness of a test commercial. So, a company wants to know the effectiveness of an advertisement. It may be examined by broadcasting the commercial a predetermined number of times, so let us say 5 times a day or 6 times a day, right, and examining the data from a pre-existing test panel. So, you have taken a test panel, you have shown the advertisement let us say 5-6 times a day and try to see whether there is an effect on the purchase or the sales of the or the buying of the particular that advertisement, whatever product was, by these respondents. Although the marketer can control the scheduling of the test commercial, you can, that means for example, once I will show the ad at 10 o'clock in the morning, then 12 o'clock, then 2 o'clock, then let us say 4 o'clock, 6 o'clock. So, 2 hours or 3 hours gap I will give and I will show the test commercial. It is uncertain when or whether the panel members, I was just telling this, are exposed to it. You are showing it, but how do you ensure that your test unit, who is a part of the experimental design, is he actually checking or looking at your advertisement, or he is maybe that particular time he has gone somewhere outside because he is doing some other work. So, in such conditions we do not have a control, okay. But then we have to live with it, that is the reality. The panel members purchases before, during and after the campaign, that means campaign is the advertisement shown, are examined to determine whether the test commercial has a short term effect, a long term effect or no effect. That means, by showing the ad number of times as we showed in the time series, we can say whether this ad, this advertisement will have a short term effect, a long term effect or a medium term effect, right. Okay. Another kind of a test in the same condition is the multiple time series design. What difference is it from that simple time series design? We will see this. In a time series design, that includes another group of test units. So, now earlier you had only the experimental group, you have now brought in the control group also, right, to serve as a control group. If the control group is carefully selected, this design can be an improvement obviously, because then it is easier for you to compare between the test of the treatment effect between the experimental group and the control group over the simple time series experiment. The improvement lies in the ability to test the treatment effect twice, right, against the pre-treatment measurements in the experimental group and against the control group. So, it is like a very normal natural you see, for example, now this group, the experimental group has 1, 2, 3, 4, 5 experiments observations before, and then after the treatment 5 observations have been taken again, right, and in the control group 5 observations was taken, no treatment was given, and then again 5 observations were taken. In fact, you can say 10 observations were taken directly, right. Now, we can check the difference, well, that may be let us say this is the first month, this is the second month, okay. So, first month 5 observations, second month 5 observations here, but here there was a treatment effect, here first month 5 observations, second month 5 observations, but no treatment effect is given. So, there we can find out the exact difference, right. So, this is what happens in a quasi experimental design, right. So, the test commercial would be shown in only a few of the test cities. Panel members in these cities would make up the experimental group, right. Panel members in cities where the commercial was not shown would become the control group. So, did you understand? That means, where the members become a part of the advertisement or they are shown the advertisement, they become a part of the experimental group, and the cities where the ad was not shown, the commercial was not shown, they are the part of the control group. So, we can measure the difference of the effect of the commercial by looking at the difference in the purchase of the people from these two cities, where the experimental group is there and where the control group is there. Example. Now, look at this, the same condition, to assess the effectiveness of a commercial, right. Two groups, experimental and control group, are exposed to an advertisement for 52 weeks both. So, the advertisement is shown for 52 weeks to the experimental group. So, experimental group is 52 weeks and control group is also 52 weeks, right. The same advertisement was shown, but what happened next? The exposed group, the experimental group was again exposed for 24 weeks and here nothing, 0, right. 24 weeks, twice as much as the control group. So, that means, so let us say the control group was shown for let us say 2 times a day, the experimental group was shown 4 times a day, twice, right, the same advertisement, right. So, you met these 24 weeks are double. So, here it is ordinary normal is the normal process going on and here it is double, the whatever it is shown once here then 2 times here, that way. The results indicated that the build up effect is because of the extra advertisement of advertising through the purchase cycle, the purchasing trends, how much purchase they are making because of the extra. This result helped in understanding the frequency and timing patterns of advertisement. So, by doing this, a company can know whether if you increase the frequency, is it going to add to your benefit, that means will the purchase increase or not, right. Similarly, what timing is the best timing to show the advertisement, that also can be checked with such an example. Okay. So, this is the example of the time series design, simple and multiple, which is a part of the quasi experimental design. So, I hope you have understood quasi experimental design. That means quasi experimental designs are very largely applied in areas of like medical science, where people cannot exactly create an experimental design. They cannot ask the suppose you want to test the effectiveness of a medicine, you can't ask a new medicine to be given to a patient until unless it is tested, right. So, there we try to create a quasi experimental study. Then we have statistical designs. Statistical designs, what happens is it consists of a series of basic experiments that allow for statistical control and analysis of the external variables. In other words, several basic experiments are conducted simultaneously. So, as the name suggests, statistical designs help you to manipulate and make some statistical inferences during the study, right. What are the advantages? First, the first advantage is the effect of more than one independent variable can be measured, right. Okay. So, earlier you were talking about, whenever you are talking about any experimental design, the quasi or wherever, you are talking about only one independent variable and try to manipulate that particular independent variable, right. So, if you would bring in more than one independent variable, then you would not be sure which independent variable is causing an effect on the dependent variable. But here in the statistical design, this offers you that advantage. Okay. Specific extraneous variables can be statistically controlled. So, extraneous variables are those variables which are not taken in the as part of the study, but they do have an effect. Okay. Economical designs can be formulated when each test unit is measured more than once. So, let us see, right. So, what are the types of statistical designs? Basically there are 3 types. The first is the randomized block design, the second is the Latin square design and the third is the factorial design. So, you can understand that this is the basic, most basic, right, most basic, and then this one is slightly better, this Latin square design, and this is even better, the factorial design is the best, right. So, let us understand what is a randomized block design. A statistical design in which the test units are blocked on the basis of an external variable to ensure that various experimental and control groups are matched closely on that particular variable of interest. Okay. Now, take this, for example, look at this. What it is saying? All treatments are allocated to the same experimental units. So, the experimental units are treated, right, all treatments are allocated to the same units, right. Treatments are allocated at random. So, the most important word is the randomization again, right. So, how many treatments are there? Now, there are let us say 4 treatments in this case A, B, C and D, right. So, A, B, C, D are the 4 treatments which have been maybe studied. Let us see an example. In the context of measuring the effectiveness of a test advertisement, we intend to measure the impact of humor. How is humor going to impact the advertisement or the effectiveness of the advertisement, right. So, 3 advertisements were made, one with let us say no humor, B, so A is no humor, B has some humor and C has high level of humor, let us say, right. Which of these is the most effective commercial? So, we want to check it, right. So, to do this we will do a randomized block design. So, management feels that the respondents evaluation of their advertisements will be influenced by the extent to which they have driven the Renault cars in the past. So, Renault driving experience is identified as the blocking variable. So, what is the blocking variable? Your driving experience, otherwise if you do not block this experience, then experience is not blocked, then it may happen that the effectiveness might be influenced by the experience of that person, right, if he has already used it, already driven that particular car. And randomly selected respondents are classified into 4 blocks: heavy, right, medium, light or never driven, right. So, the blocking variable is basically the one where, that means you have created 4 groups and this 4, that is what you want to test, right. So, how do these people, the users, in this block is of the users of the car, how do they respond to the test commercials ABC, which is no humor, slight humor and large amount of humor. Let us understand it again, let me clarify. So, what it is happening, there is one thing that you want to check, ki whether the test commercials do have an effect on the driver or on the experience of the driver, let us say. So, how does the effectiveness of the ad, let us say we are measuring the effectiveness of the ad. So, how effective the ad is if we take in 3 levels of humor: no humor, some humor and total large amount of humor. But then on what basis are you dividing the test units? Now, the test units are divided on basis of the level of experience of the drivers. The level of experience could be a heavy driver, that means he is always driving this particular car. Medium driver, somebody who is being driving for maybe last for few years only and not much. Light, or somebody who has never driven and now he is also being exposed to this commercial, right, 3 type of commercials, some humor, no humor and heavy humor. So, now how would it react? So, what reaction would it show? Let us see. So, the example is the block number is 1, 2, 3, 4. So, the usage which is the on which we have built the block is high, medium, light and none. This is the experience, right, experience. So, advertisement A, B and C are randomly the randomized block, this is a randomized way the blocks are they are put into the blocks, right. So, when you put in, let us say now usage is high advertisement A. So, this is the first condition. High B, that means this is no humor, some humor and all humor, right. So, high no humor, high experience some humor, high experience all humor, medium. So, how would they react? How would this each condition, each test, in each cell, what would be the reaction pattern, right. So, we have to measure, and by measuring this we can say ki which kind of advertisement is affecting whom in what way, right. But the main limitation of the randomized block design is the researcher can control for only one external variable, only one, right. When more than one variable must be controlled, the researcher must use the other 2 designs, the Latin square and the factorial design, right. So, we have understood the randomized block design. Now, we will go to the next one, which is the Latin square design, which is an improvement over the randomized block design. Okay. In this, what happens, the statistical control for 2 non-interacting external variables is taken. So, earlier you were talking about only one variable, now you have a scope for 2 variables, but the condition is they should be non-interactive in nature, right. That means A and B, the result of A and B should not get affected by the presence of each other. Each external or blocking variable is divided into an equal number of blocks or levels. So, that means this is another problem sometimes of a Latin square design. The number of rows, that means it should be a 3 cross 3 matrix or 2 cross 2 matrix to 4 cross 4 matrix, but not a 3 cross 4 matrix. You cannot take it, unequal is not possible, and the number of treatment is also has to be the same. That means, for example, the treatment in the last case was humor. So, some humor, all humor and no humor, right. A Latin square is conceptualized as a table with the rows and columns representing the blocks in the 2 external variables. So, we explained the labels of the independent variable are then assigned to the cells. Okay. The assignment rule is that each label of the independent variable should appear only once in each row and each column. You cannot repeat it. Okay. Now, look at this. Now, same condition, the usage, now we have what we have done is we have clubbed this together to make it a 3 because there were 3 things here. So, high, medium, low. So, what is happening? Interest in watching Formula 1 races, right. So, people have been taken and these are the commercials ABC. So, 2 variables have been taken, the experience, high experience, medium experience and light or no experience. Now, people, how much interest people have, right, for watching the Formula 1 races where this Renault car is being used, let us say. So, that is also been taken. So, and this is high, medium and low. So, high interest, medium interest and low interest. So, you have 2 variables now, interest and usage. Okay. Now, the test commercials are randomly again placed inside, right, and you have to ensure that in each cell, each let us say row, it has to be only one. So, B, let us say A and C. So, this is again C, B, A. Now, you can see there is no repetition anywhere, neither in the vertically nor in the horizontal side, right, and each has been given only one opportunity. So, now after doing this, we again run this design, but the limitation of the Latin square design is that they require an equal number of rows and columns and treatment levels, which is sometimes problematic, right. In addition, only 2 external variables can be controlled and not more than that. Third, interaction effects are not allowed. Okay. So, this is a big issue because in real life interaction does happen because of the presence of one or other variable, there is an interaction. So, that you cannot assume that it will not happen, right. So, to examine the interactions, now we have come to an improvement and a new kind of a study, which is the factorial design. But today I will wind up here. Let me just summarize what we have done. So, in the next lecture we will talk about the factorial design and we will close this chapter. So, basically we talked about the quasi experimental and then we came to the statistical designs. In the quasi experimental we talked about the time series and the multi time series, right, and we said ki quasi experimental is done when randomization is not possible and a true experiment is not possible. So, the researcher tends to make it look like resemble something to a true experimental, but not an exact experimental study. Then we said a statistical design is an improvement over the others. Now, what is happening here? You can take more than one variable, right, independent variable and test it, right. So, here we saw the first is the randomized block design in which we took one independent variable and tried to see the effect, right, of some kind of a treatment. Then we came to the Latin square design, which is better than the first one, but then it has some limitations like interaction effects are not possible, only a maximum 2 independent variables you can take. So, these are something that we found was also an advantage, but also a limitation, right. So, we will go to the third design in the next lecture. We will talk about the factorial design, which is highly utilized in all kind of experimental studies in social science and other places and even basic science, right. So, thank you for today. We will meet in the next lecture.